This video shows the determination of the area bounded by the functions y is sine of x with y as cosine of x. Check how it is done here in integral calculus. The problem states, determine the area bounded by the curves y as sine of x with y as cosine of x from the interval of 0 to 2 pi. Check out the given information. First, the equations of the two curves are given. Those are y as sine of x and y as cosine of x. Another is the Cartesian plane to be used in sketching the curves. For trigonometric functions, a rectangular plane is still possible, where the y-axis contains real numbers. The x-axis, however, will be in terms of radians, and providing the scale can be done in the best suited manner according to the details of the solution. The first step for the solution is to sketch the curves. Sine and cosine functions are periodic, and one easy way to determine coordinates is through substitution. By making a table, it would be easier to identify points, but before computing, take note that these functions are in radians. Start off with the first curve, y is sine of x. If x is 0, y is sine of 0, or that is 0. Next, if x is pi over 2, y is sine of pi over 2, giving 1. Then if x is pi, sine of pi is 0. Also, with x as 3/2 of pi, y turns out as negative 1. Then if x is 2 pi, y is computed as sine of 2 pi, which is 0 again. Trace out the points and see that the curve is a periodic wave. Do the same substitution with the other function, y as cosine of x. If x is 0, y is cosine of 0, which is 1. If x is half of pi, y is cosine of pi over 2, which is 0. Then if x is pi, y is cosine of pi, which is negative 1. There is also x as 3/2 of pi, giving y as 0. Then, if x is 2 pi, y is cosine of 2 pi, which is 1. The other parameter in the premise is the interval from 0 to 2 pi. This information helps in identifying boundaries for the area, which is shown as the enclosed area from 0 and before 3/2 pi. Another method of sketching the curves of trigonometric functions is by interpreting the period of the functions. From physics, it was discussed that a period contains a full wave, and for sine and cosine functions, the period is identified from the general form y as equal to a times sine of b times x less h plus k. From the equation, a is the amplitude of the wave, that is, the height of the wave. H is the horizontal shift, which shows the horizontal movement of the wave from the origin, which is similar to k, the vertical shift, or the vertical movement of the wave. Then the period is computed as 2 pi over b, where b is the coefficient of x. So start by looking for the period of y as sine of x. 2 pi over 1 is 2 pi, which means that the whole wave has the wavelength of 2 pi, and half of the wave is pi. For sine, the start of the wave is on 0, as shown from the substitution of 0 as x. Next is for the period of cosine x, which is 2 pi over 1, giving the same 2 pi, Then the curve starts at 1, so the wave shifts a little to the right, making the bounded area visible. Knowing the area to determine, the next step is to decide which strip is suitable for the analysis. The simple concept of working with the strips is to have the two ends of the strip touch the two functions. Check if the horizontal strips are possible. If a horizontal strip is placed at the middle, it is quite obvious that the left end touches the red curve, and the right end touches the yellow curve. But moving a bit above the area, both the strip ends touch the yellow curve, and further below the area, both ends of the strip also touch the red curve. This shows that the horizontal strip is not suitable. So check vertical strips. By placing vertical strips from the smaller parts of the area to the wider parts, have both ends of each strip touch both the functions, sine of x and cosine of x, so we use vertical elements. The next step is to determine the boundaries of the area. Since we figured out that vertical strips are to be used, we find the left and right boundaries. These boundaries are the actual limits of the integral. Graphically, the limits are from the locations just after 0 and before 3/2 of pi. But what are the exact placements? This we can find by equating the two functions. Y is equal to y, and that is, sine of x is cosine of x. Divide both sides by cosine of x, so sine over cosine is tangent of x, and cosine over cosine is 1. Identify x by taking the arctangent of 1, which gives a quarter of pi. That is the first point. We identified one limit, but how about the other boundary? Recall that the tangent function is also periodic, which means that the two curves will again intersect at exactly pi distance, which means the next intersection is at x equal to 5/4 of pi. Then, the next after that is on 9/4 of pi, and so on. The next component of the integral to figure out is the expression itself. Instead of using so many formulas for different orientations, we work with the simple formula of a rectangle, as this is similar to one strip. Because we are using a single strip, which has a minimal area, we state its area as d of a. The width of the rectangular strip is dx, and its length is y. So d of a is just y times dx. The next thing to consider is identifying y. But since we are using a Cartesian plane, we can simply find the ends of each strip, take their difference, and have that as the length of the strip. In mathematical computation, we can say the location of the upper end of y minus the coordinate of the lower end of y. Since these two ends keep on moving due to the nature of the curve, we don't have a definite value, but still we can use the functions. Now complete the expression. The derivative of a is the upper y, or sine of x, minus the lower y, which is the red curve, or cosine of x. Then multiply the with dx. To eliminate derivatives, integrate the whole equation. So the integral of d of a is a, then the right side of the equation is the integral of sine of x minus cosine of x times dx, from 5/4 of pi to a quarter of pi. With the formula already identified, move on to integration. The integral of sine of x is negative cosine of x, and the integral of cosine of x is sine of x. Plug the upper and lower limits from 5/4 of pi to 1/4 of pi. Substitute the limits, making the integral of negative cosine of 5/4 of pi minus sine of 5/4 of pi. Then subtract the lower limit, or negative cosine of 1/4 of pi minus sine of 1/4 of pi, simplified as 2 root of 2 square units.